Hey guys, today I want to talk about the normal distribution. I've taken time without updating my YouTube channel because I've been so busy with studies, but I'm now done and I want to start off from where I left last time. We had talked about the continuous random variables and the discrete random variables. So today we want to talk about the normal distribution as a continuous random variable. In probability theory and statistics, the normal distribution is the normal distribution. Sometimes we can call it the Gaussian distribution, but this is a bit rare, so I'll not skip it. Let me write it here. Called the Gaussian distribution. Is the most significant continuous probability distribution. Sometimes the normal distribution is called a bell curve. So we are going to discuss the normal distribution here, and we will use normal distribution because that's what is mostly common. But if you find Gaussian distribution, still it means normal distribution. Okay, yeah, so barrel shape, Gaussian, those are not so common, but they all refer to the normal distribution. So what is the definition of a normal distribution? So let's talk about normal distribution definition. Distribution definition. So the normal distribution is defined by the probability density function for a continuous random variable in a system. So we are saying that the normal distribution is defined by the probability density function for a continuous random variable in a system. So what's the formula for the normal distribution? Normal distribution formula. Okay, we know the probability density function. We discussed the PDF in a continuous and discrete random variables. So this is the term you must be familiar with. The probability density function, okay, of a normal or Gaussian distribution is given by, so it is f of x mu and sigma. It's defined as 1 out of sigma times the square root of 2 pi, then the exponential to power minus of x minus mu squared divided by thrice sigma squared. So this function is defined for the minus infinity less x less infinity. Okay, we use minus infinity and positive infinity to refer to the lower limit and the upper limit. Okay, does not necessarily mean that they are going to be negative and positive. No. Okay, so most books write f of x mu and sigma as simply f of x equal to 1 divided by sigma, then root of 2 pi, then the exponent of minus x minus mu squared divided by thrice sigma squared. Okay, you will simply find it as f of x. It is defined for minus infinity lower limit less x, okay, less the upper limit. So that is the function. This is a theoretical function, you know. Yeah. people who studied this and wrote it down, they found that the probabilities were defined by this function. So this is the probability density function. We sometimes call it PDF of a normal distribution. It is somehow complicated and you are not expected to memorize it. No, nobody will ask you about that, but it is the function that will give us probabilities, which we are going to see just shortly ahead. In just a minute, we will be talking about that. All right, so what's x, what's mu, and what's sigma? That's what we need to know. What's x here? X here is the variable, okay? And then mu is the mean, then sigma is the standard deviation, I'll go ahead and tell you something a little bit about standard deviation. When I'm recording these videos, what I put into consideration first is the size of the video I'm producing. I know some people use mobile data to access this information. So if I make my files very big, then it's going to cause you some good financial, okay? Yeah, you're going to incur a lot of money to access the videos. But if I try and make a video that is very light, then you spend less on data. So what I do when I'm writing, I don't record when I'm writing because it takes time. Yeah, so right now I want to talk about the normal distribution standard deviation. Okay, let's talk about normal distribution standard deviation. Okay, so generally, the normal distribution has any positive standard deviation. The mean helps to determine the line of symmetry of a graph, whereas the standard deviation helps to know how far the data are spread out. Okay, so let me give you this information because you need it. If the standard deviation is smaller, the data are somewhat close to each other and the graph becomes narrower. Okay, so a small standard deviation means that the curve will be very narrow. You know, we are going to talk about the barrel-shaped nature of the curve and we see how it gets narrow when the standard deviation is small. If the standard deviation is larger, the data are dispersed more and the graph becomes wider. So the shape, okay, how wide or how narrow the graph is determined by the standard deviation. Every normal distribution curve will be symmetric about the mean. So the mean is the line of symmetry and the standard deviation is a measure of how the values are close to each other. Okay, so we are going to start the standard deviation are used to subdivide the area under the normal curve. Okay, each subdivided section defines the percentage of data which falls into the specific region of the graph. So I'm just giving you this information because you need it before we start discussing the curve and then trying to see how we get probabilities. So let me give you some more information here before I go ahead and try to talk to you about the standard normal distribution. Using one standard deviation, the empirical rule states that approximately 68% of the data falls within one standard deviation of the mean. Okay, 95% of the data falls within two standard deviation of the mean, and about 99.7% of the data falls within three standard deviations of the mean. So this is what we are saying. We have a normal curve here. This is the normal curve. It is bell-shaped. And it is symmetric about the mean mu. So this is the mean mu. Okay, these are x values on the horizontal axis. So about 68% falls within, this is mu plus 1 standard deviation, and this is mu minus 1 standard deviation. So this area here, okay, let me use a continuous line. This area is about 0.68, okay. Approximately 68% of the data is within 1 standard deviation of the mean. So this is 68%, the area, okay. Then about 95% is within 2 standard deviations of the mean. So if I move right here, let me change the color and use blue. So right here, and somewhere here, which is mu minus twice the standard deviation, and this is mu plus twice the standard deviation, okay. This is twice the standard deviation. So this area, the area swept, is about 95%. This 95%. I'll explain this more, okay. And about 99.7 is within 3 standard deviations of the mean. So I'll change and use a color. I don't know whether this will work out. Let me use red. Okay, so this is mu minus 3 standard deviations, okay, and this is mu plus 3 standard deviations. So this right here is about 99.7%. So what's the interpretation? Okay, let me talk about the last one by drawing here another curve. I have a normal curve here. It's symmetric about the mean. Okay, this is the sketch. So this is the mean mu, and this is mu minus 3, okay, and then this is mu plus 3 standard deviations. So this area here under, okay, is 0.997, okay. Approximately 99.7% of the data is within 3 standard deviations of the mean. If we say within, okay, 2 standard deviations of the mean, it means that mu minus 3 standard deviation less x less mu plus 3 standard deviations. If we say within 2 standard deviations of the mean, then this is mu minus 2 standard deviations less or equal to x less or equal to mu plus 3 plus 2 standard deviations. Okay, so the meaning of within is should be interpreted from mu minus up to mu plus, okay. It is symmetric about the mean. If we say within 1 standard deviation of the mean, so this is mu minus 1 standard deviation less x less mu plus 1 standard deviation. So that statement should really be well interpreted and should be clear to every student, okay, because it will appear on any exam when they say within 3 standard deviations of the mean, within 2 standard deviations of the mean, within 1.5 standard deviations of the mean, okay. So should be well interpreted. Okay, there are some properties of the normal distribution. So let's talk about the properties of the normal distribution. Okay, the normal distribution. So in the normal distribution, the mean, the median, and the mode are equal. So the mean, the median, and the mode will always coincide. Okay, that's the first property. Then the total area under the curve is equal to 1. So the total area under the curve should be equal to 1. So this is the normal curve. always symmetric about the mean. Okay, here, this is the mean. Mu, okay, is the mean, which should be equal to the mode, and it should be equal to the median, okay, because it coincides. But what we are saying is the total area under this curve, okay? This curve is running from minus infinity up to positive infinity, from the lower limit up the upper limit. So the area should be equal to 1. Okay, and it is a property of all random variables. You know, a variable is random if the sum of probability is equal to 1. In the case of the normal distribution, probabilities are proportional to the area under the curve. So if the total area under the curve is 1, then that qualifies to be a normal distribution. Okay, there is this other property. Property number 3 is there should be exactly half of the values to the left of the center and exactly half of the values at the right of the center. Okay. The normally distributed curves should be symmetric at the mean or at the center. Distributed curves should be symmetric at the center. Since the mean is at the center, so the normally distributed curves are symmetric about the mean. So there are lots of properties, but let me see. We have the normal distribution to be defined by the mean and standard deviation. Okay, the normal distribution should be defined by the mean and the standard deviation. So the normal distribution curve must have only one peak. So the curve approaches the x-axis but never touches it, and it extends further from the mean, okay? So the curve approaches the x-axis asymptotically, okay? And it extends further away from the mean. Okay, so those are some of the properties of the normal. Let me explain some of these properties to you. If we have a normal curve here, let me draw just a sketch. I'm not really doing it accurately. But if we have a normal curve, then what we are saying is, okay, the horizontal line is a line that gives us the x values. And then there is symmetry about the mean. So if this is the mean mu, Then to the left of the mean, we have an area which will be 0.5. And then to the right, we have an equal area, 0.5, since the total area under this curve must be equal to 1. So the mean divides the curve symmetrically. Now, we must have half of the values on the left and half of the values on the right of the mean. So, for example, if let me say my mean here is equal to 50. So, if this value here is 60, then the value here will be 40. If the value here is 70, then the value here will be 30. If the value here is 80, then the value here should be, 20. Okay, you have exactly the same values on the left as values on the right. They're exactly the same and equal. Okay, now when we look at the case of a standard normal, what do we call a standard normal? We're going to learn more about the standard normal. Okay, what we call a standard normal, it is that normal distribution with mean 0, okay, and the standard deviation 1. So for a standard normal, okay, since the mean is 0, it means that what we have here, let me try to improve on my graph. Okay, so I have a normal distribution right here with the mean 0. Okay, so if this value is 1, then this is going to be negative 1. If this is 2, and then this is going to be negative 2. Okay, if this is 3, this is going to be minus 3. So a standard normal looks somehow like that. Okay, and then since the mean divides the area symmetrically, the area on the right here is 0.5 and the area on the left is 0.5. Then this normal curve has only one peak. Okay, it has that at the highest point. Then it approaches the x-axis. It keeps getting closer and closer to the x-axis but never touching it. So we say it approaches the x-axis asymptotically. Okay, so these are some of the properties of the normal curve. Okay, there are some applications of the normal curve. The normal distribution is closely associated with many things, such as if you give a test or an exam, the marks scored by students on a test normally follow a normal distribution. And the heights of people, also for a normal distribution. And we have the size of objects produced by a machine, also the blood pressure. We have the weights of babies at birth. So there is a lot of applications. Okay, so let's write down some of the applications of the normal distribution.